This video is going to be on solving proportions using cross products. If you haven't looked to see what ratios of proportions are on the last video, you should go ahead and take a look at it. There is a PDF on the notes on this. You can go ahead and print that out if you like. First off, we're going to talk about what a cross product is. In a proportion, remember two ratios that are equal is called a proportion. The cross product is the product, that means multiplication, of the numerator of one ratio. Probably should have underlined that. One ratio. The numerator of one ratio with the denominator. So the numerator of one ratio multiplied with the denominator of the other ratio. Cross products of a proportion are equal. That's very important to understand. That's what allows us to solve these things quicker than what we did in the last video. When we cross multiply, the two answers of those multiplications are equivalent. So 3 over 4 is equal to 6 over 8. And if we do 4 times 6, which is the cross product here, we get 24, and then 3 times 8, which is the cross product here, we get 24, and you can see the two cross products are actually equal to each other. So set up in the general form of A to B, A over B, a ratio of A to B is equal to C over D, we can cross multiply like this. A times D is AD, and that's going to equal B times C, which is BC. And it's because of that cross product being equal, it allows us to simplify and solve proportions really easily. Here's an example. I like to multiply the variable first, but you don't have to. X times 6 gives you 6x. And then come down and cross multiply here. 8 times 15, and make sure you use a calculator. 120. So 6 times x, or 6x, is going to equal 120. And then all we got to do is divide by 6 on both sides. This becomes a 1. 1 times x is just x. And 120 divided by 6 is going to give you 20. So the value of x here, it should be 20 to make this ratio equal this ratio. Again, I mentioned this in the last video. You'll notice how the denominator here is bigger than the numerator. So we would expect the value of x to be bigger than the numerator on this side as well. If that doesn't actually happen out the way you expected, then that means you probably made a mistake in the actual calculation of the proportion. We're still going to do a multiply here. They both have x's, so I'm going to do the one that has only one term on it. So x times 8 first. So 8 times x is 8x. And over here, this is 4 times the entire expression. So you should rewrite it like this. And now it turns into a multi-step equation where you have a variable on both sides. So the proportions can be solved using the multi-step equation process with variables on both sides. We still need to distribute our 4. So I have 8x is equal to 4 times x is 4x, and 4 times a negative 3 is going to give you a negative 12. At this point, I see that I have less x's on this side than I do over here, so I'm going to go ahead and minus 4x's from both sides. 8x minus 4x leaves us with 4x's here. 4x minus 4x is 0. 0 minus 12 is negative 12. And now all I got to do is divide by 4 on both sides, so that x now equals negative 3. If you'd like to try this one without seeing the solution, go ahead and pause the video. I'm going to multiply this one first because this has the single term in the numerator. So m times 4 is going to give us 4m. Remember, this is a grouping all up in the top, so m times the entire group. Or sorry, 5 times the entire group. And 4m is going to equal, distribute, 5m. 5 times negative 6 is negative 30. Now these m's are smaller than those, so I'm still going to go ahead and subtract my 4 m's from both sides. But since this is a 0 and I have nothing else left over there, I actually have to leave a 0 there to hold the place value. 5 m's minus 4 m's leaves you with 1 times m, or just m, minus 30. And I'm just going to add 30 to both sides to get m by itself, so that m is going to equal 30. So 30 here, 30 there. Okay, word problem. Each day seals in an aquarium are fed 8 pounds of food for every 100 pounds of weight. So food compared to weight. Seals at the aquarium seal at the aquarium weighs 280 pounds. How much food? The question is in terms of food. How much food should be fed to the seal each day? So as they start with food, so I'm going to put food over weight. So it's a ratio of how much food they give them to how much they weigh. So I'm going to keep that format, food over weight. So the first thing they gave me was 8 pounds of food compared to 100 pounds of body weight. Now, since this is food over weight, I got to put food over weight on this side. So this number they give me, 280 pounds, is not the amount of food, but the weight of the seal, and the weight goes in the bottom, so I put the 280 pounds at the bottom. And since I'm solving for food, which is the top number, I'm going to go ahead and use the letter F to represent the food. Solve this by cross multiplying. 100 times F equals 100 F. Cross multiply here, 8 times 280. And that gives us, times 8, 2240. And all we got to do now is divide by 100. This becomes a 1. 1 times F is F. And 2240 divided by 100 should give us 22.4 pounds of food. Just double check that. 22.4 pounds of food. So a 280 pound seal requires 22.4 pounds, almost 22.5 pounds of food every day. Also related to ratios and proportion are something called scale drawings and models, and then something called the scale. Well, scale drawing is simply a two-dimensional drawing. That means it's a flat drawing in which the dimensions of the drawing are in proportion to the dimensions of the actual object. Okay, so we can create a proportion between the dimensions of the drawing to the dimensions of the actual object. Scale model is essentially the same thing as a scale drawing, only it's a three-dimensional figure instead of a flat two-dimensional drawing. So it's a three-dimensional model, but the dimensions of the model, I put drawing there, but it should be model, are still in proportion to the dimensions of the actual object. And the scale is referred to as the ratio of the model dimensions or drawing dimensions to the actual dimensions. So we always go scale to actual. We usually write it like this: scale first, actual second. So if you're to solve this in a proportion, you would set whatever scale that they give you up like this, scale over actual. So most of the time, not every time, but most of the time, in a proportion, the top number is the scale or model drawing, or a model amount, and the bottom number represents the actual amount. Here's a house floor plan, and right here they tell us the scale of 1 inch to 12 feet. So what that means is in the drawing, for every 1 inch that we measure, it's actually representing 12 feet of real life building. And these kinds of plans with these scales are used to actually build houses, cars, whatever. Maps, you see maps with scales all the time. This one says use a metric ruler and the map to estimate the distance between, they do say estimate because it's not perfect, between Cleveland and Cincinnati. So Cleveland's here, Cincinnati is over here. And let's suppose we put a ruler on there and we measure that to be 4.2 centimeters. We can see right here there is a scale in the map. So somewhere on all your maps, as long as they're drawn to scale, should have a scale for you. That says 1 centimeter is to 85 kilometers of real life. Okay, so right here, this is 4.2 centimeters. That's my map drawing, my scale drawing, or scale measurement. So that would go in the numerator. We can also tell because it's using the same units of measure, but we also measured it here. That measurement was 4.2 on the map, not the actual distance. And then we're solving for kilometers. We don't know what it is, so I'm going to go ahead and put a K there. I'll multiply here. 1 times K equals K. And then over here we're going to multiply 85 times 4.2, so 85 times 4.2. Let's try that again, 85 times 4.2. And we get 357 kilometers. So even though the distance between Cincinnati and Cleveland on the map is 4.2 centimeters, the real distance would be 357 kilometers. And of course, if you want to know what that is in terms of miles, you'd have to go and do a conversion from kilometers to miles.